Number 5, is 210 a solution to the system? So let's try it. Let me call this one equation 1. Let me call this one equation 2. Okay, so equation 1 is negative 3x minus 4y equal negative 4. So in the pair 2, 10, of course, 2 is x and y is 10, right? Just like the alphabet, x comes before y. So let's plug in 2 for x. I got negative 3 times 2, because that's, of course, what negative 3x means. It means negative 3 times x minus 4y. Y is 10, so I'm putting negative 4 times 10, because, again, negative 4y means negative 4 times y. That's equal to negative 4. Okay, what's this part right here? Negative 3 times 2, that's negative 6. What's negative 4 times 10? That's negative 40, right? Negative 40 equal to negative 4. Negative 40 minus 6, same signs add, keep sign, that's negative 46 equal to negative 4. Is this true? Does negative 46 ever equal negative 4? No. Okay, so if it does not work in the first equation, it doesn't matter whether it works in the second equation, because for this point to be a solution, it must work in both equations. And so again, we're going to say, no, this point is not a solution. And again, here's my work to show it. Number 6, show each step to rewrite the equation into slope-intercept form. So we've already been talking about how slope-intercept form is y equal mx plus b, right? We need y equal mx plus b. So we are basically solving this equation for y. We want y on one side and everything else on the other side. Okay, so which side of the equation is our y on? Well, y is on this side, right? The left side. I have nothing over here. So I could choose to leave the y term right here and move 7x to the right side and move 28 to the right side. That would certainly be okay. But what I could do instead, I would have to move one less term. I could just move the 2y over here, and the y term would already be by itself. So how can I move the y term to the right side? Well, as you can see right now, it's being subtracted. It says minus 2y. So how do I undo subtraction? I undo subtraction by addition. So I add 2y, of course, to the left side and to the right side. Now, there are some of you who don't do this correctly. You cannot just put plus 2. That is not mathematically correct. This term right here is a negative 2y. It's negative 2 times y. So to get it to cancel on this side, I cannot just add 2. I have to add exactly what this is. This is a negative 2y. So to undo it, I must put a positive 2y, or add 2y to both sides, so that these will cancel. Okay, now what I'm left with is, on the left side, I got 7x. I bring it down. I bring the plus 28 down. I bring my equal sign down. Over here, I have a 2y. Okay, so I'm on the way to getting y by itself. This is 2 times y, 2y. That's what 2 times y means, or 2y means. How do I undo multiplication? I undo multiplication by division. So I'm going to divide every term in the entire equation by 2. Okay, so on this side, I'm going to have just y, and I'll have 7 over 2, 7 over 2, which I need to leave as an improper fraction. Leave this as an improper fraction. Don't make it a decimal. That's not going to help you if you were to graph this on the coordinate plane. You need to know what it is as an improper fraction. So this is 7 halves x. 7 halves x. Then you got 28 over 2. That's positive 14. Okay? So I'm going to write this equation with my y first. So y equals, then I'll put my x term. Here's my x term, 7 halves x. Then I'll put my constant term. Here's my constant term, positive 14. This right here is in slope-intercept form. Now I can identify my m. Of course, m is the number in front of x, which would be 7/2. That's my slope, 7/2. And b is the constant term, which is 14. I know it's positive 14 because of the plus sign. So b is 14. Number 7, show each step to rewrite the equation in slope-intercept form. I see y is on the left side, so everything else must be on the other side. So move the 3x to the right side by subtraction. So I'll put -3. Nope. -3 what? What does the 3x have on it? It has a 3x. 3x. So to undo the 3x, I must subtract, not 3, I must subtract 3x, of course, from both sides. Okay, so that those 3x's will cancel. Now, what is this term right here? That term is not 2y. That term is negative 2y. I know it's negative because of the minus sign. So negative 2y is what I will write down. Equals. Now put my x term first. My x term is negative 3x. Then I'll put my constant. This is a 12 or a positive 12. Now, I need to solve for y. So this is negative 2y or negative 2 times y. How do I undo multiplication? I undo multiplication by division. All right, so I'm going to divide by what? What is the number in front of y? What is this number? What is this number right here? What is that number? Is that number 2? Nope, that is not a 2. That is not a 2. That is a negative 2. And so that is the number that I should divide every single term in the equation by. Negative 2. I divide by negative 2. I divide by negative 2. I must divide every term in the equation by the same exact thing so that I don't change the equation. When I do that, these negative 2 simplify, so I got negative 2 equals. Now, look right here. I have a negative over a negative. I know a negative over a negative is going to be a positive, okay? So it's going to be a positive something. Don't change this to a decimal. I just need 3 over 2, positive 3 over 2, x. Okay, then you got 12 over negative 2. What's 12 divided by negative 2? Negative 6. So this right here is slope-intercept form. What's m? M is the number in front of x. So that'd be 3/2. M is 3/2. B is my constant term. Is that term right there a 6? Nope, not a 6. I know it's not a 6 because it doesn't say plus 6. It says -6. So this is a negative 6. That's where it will cross the y-axis at negative 6. Okay, we're going to solve one using solve systems by graphing. So first, step 1 is to write each equation in slope-intercept form, which we've just practiced. That's y equals mx plus b, where m is the slope and b is the y-intercept. Step 2, graph each equation on the same coordinate plane. To do that, we'll begin with b and we'll move with m. Then we'll draw a line through the points, and then we're going to look for where the lines intersect. Where do they cross? Because wherever they cross at, that is the solution to the system. Okay? Then we can check to see if that's the solution by substituting it into both of the original equations, just like we did right here, number 4 and number 5. Okay? So, number 8, last one here, solve the system by graphing. So step 1, put the equations in slope-intercept form if they are not already. So let me call this first one equation 1, and this will be equation 2. Now, equation 1, is it in slope-intercept form? Looks like it. It says y equals mx plus b. M is 2, since that is the number in front of x. What's my b? What is the constant term? Negative 3, right? All right, what about equation 2? Is this in slope-intercept form? Yep. What is m? M is the number before x, so that'd be negative 3. What is b? What is the constant term? The constant term is this one, 2. Okay, so I'm going to use that information to graph these lines on the coordinate plane. So step 1 was sort of already done for me. The equations were already in slope-intercept form, but if they're not, I need to put them in slope-intercept form so that I can identify m and b. So let's graph equation 1. Well, we're going to begin with b. Where is b in equation number 1? it is -3, right? I'm looking at this right here right now. So -3 is where I'm going to put my first dot. So I'll change my thickness over here to 8 so I can put a dot on -3. Okay, here's the y-axis, right? This is the x-axis. This is the y-axis. Okay, so -3 is -1, -2, -3. I put a dot right there. Now that's where I begin. Then I move with m. M is 2, right? So if I write 2 as a fraction, would you agree this is 2 over 1? So this tells me I should rise 2 and go to the right 1. Up 2, right 1. So from B, I'm going to go up 2. I'm going to go up 2, 1, 2, to the right 1, and put a dot. Then I'll go up 2, 1, 2, to the right 1, put a dot. Now, instead of going up 2, right 1, I could change the direction of both these arrows and go down into the left. So up and to the right is the same thing as down and to the left. So let's put dots. Let me start here from this B and go down 2, 1, 2, to the left 1, and put a dot. Okay, now I need to make my line here, so I'll go Shapes, Insert Line, and I'll click and drag to make this line. Okay, because it's a line, it needs arrows on the end of the line so that I can tell that the line continues forever in both directions, because that is, of course, what a line does. It never ends in either direction. Okay, I will also label that this is line 1 by putting a 1 and circling it at the very end of the line. Okay, equation 2 now. I need to begin with B. B is at 2, so I'm going to put a dot at 2. I'm going to put a dot at 2 on the y-axis. So here's the y-axis, 1, 2. Okay, make this a little thicker. Okay, that's B. That's where I will begin. Then I'm going to move with M. M is -3, so it's -3 over 1, right? That's -3 as a fraction. So this tells me if it's -3, I'm not going to go up 3. I'm going to go down 3. And if it's +1 on the bottom, that means I'm going to go right 1. So down 3, right 1 from B. Here's B. Let's go down 3. 1, 2, 3 to the right 1. Boom, dot. Down 3, 1, 2, 3 to the right 1. I could also go the opposite direction. Instead of going down to the right, I could go up and to the left from B. Let's try that. From B, up 3, 1, 2, 3, left 1, and I would still be on the line. Okay, connect my line here. I'll go Shapes, Line, and connect right here. Okay, arrows on the end of the line to show that it continues forever in both directions. Okay, so I did step 1. The equations were already in slope-intercept form. I identified M and B. Step 2, I graphed each line by beginning with B and moving with M. Now, step 3, find the point of intersection of the two lines. The point of intersection, as you can see, is right here. Right here. Okay, so that point right there is the solution to the system. So I need to figure out what is the ordered pair there. Well, when doing the ordered pair, I start at the origin, and to get right here, I would go right 1 and down 1. Right 1, that's 1. Down 1, that's -1. Okay, so that's my ordered pair. 1, -1. 1, -1, that is my solution. So that's what I'll put right here. 1, -1. 1, -1. Okay, I could check this by plugging it into both equations. So if I do that, if I plug in 1, -1, 1, -1, since I'm running low on space here, I won't require you to do this, but you could always check if this was my x point and this was my y point. All right, I would have -1 on this side because that's what y is. I would have 2 times x, or 2 times 1, which is 2, minus 3. Okay, so this side would be -1, right? -1 equal -1. Over here, if I plug -1 in for y and do -3 times 1, since x is 1, -3 times 1 is -3. -3 plus 2 is -1. Okay, so yes, this point works in both equations. And so, yes, it is, in fact, the solution to the system. 1, -1.